In this video, I'm going to show you how to make an RPG element system. You know, every RPG seems to have a little bit of a variation on this. Also, this tutorial would not be complete if I didn't show you how to make a little bit of a visual effect. So let's talk about how to do it. Recently, I hosted a game jam. It was very cool and very fun. You can check it out in a link below. I ended up programming this weird little Pokemon skill crane game thing. So let's take a look at this project. Basically what we have here is we have 3 different main types with a couple extras that are all RNG'd into this box. Once you get enough of them, you get 3, then they go into this auto battler with a typo, and they attack each other. You can't really tell because I didn't have that much time because this is a game jam, but there's an element system at play here that determines how hard the hits are when the characters attack each other. Now, you've seen this before in games like Pokemon and stuff. So let's bring up like the Pokemon type chart here. I'm going to assume that 2 is super effective here, and then these halves are like halfway effective, right? So this is kind of nice actually because it explicitly states there's a 2x effect on fire to grass, basically, the attacker-defender relationship. And it also explains all the others here too. I don't know what generation this is or if this is totally accurate. Here's the type chart that I made. I know this looks super confusing, but I'll explain my methods here a little bit. You can make a chart like we saw with the Pokemon chart, but it gets really confusing to instantly visually see what's good against what, especially if you're going to be adding more elements. So here's my system from Swiper Claw. You can see heat is effective against soft because it moves like this. I imagine, you know, like fire burns fabric. That was kind of the idea. The arrow, whatever arrow is up against it, determines the direction of effectiveness. Now, my system's sort of bidirectional here, right? So if chill is effective against heat, then heat is ineffective against chill. And that's sort of a simple way of doing it, but you can kind of program the strengths and weaknesses, whatever you want, using our system. We're going to make a system today that's equally simple, but I'll show you how you can customize it and how you can push it even further if you want to. This program is Simple Mind. It's something I really like a lot. A lot of the mind mapping services out there are subscription. This one, you just pay once. All right, now let me show you what's going on in this project. I have some regrets here because it's a game jam project. It's going to be messy, but don't worry, we're going to be fine. Most of the logic for the type systems are in 2 places. One is in this Fluffy Monster parent class. This class has a lot going on with it. But one of the things that it has is down here, sorry, nothing's commented, once again, this is a game jam, is we have our typing system. So I'll go into this code and what it means. Currently, this gets called, and it sets a variable at the end of the call. We have a data table set up for this. And then it goes through a bunch of different conditions to see if any of these lists contain our character's type. Now, if you found that confusing, don't even worry about it. We're going to be starting over from scratch in just a minute. So here's all my different types. They all have different names in this enum. You can see them all here. They're the same ones from my chart. And then here are all the different matchups. These are data tables that have names that are the same as all of the different type enums. And then they have these arrays inside them. These are all determined by a specific struct. I'll show you how to set all this up. This is basically all we got to do. All right, so let's go make a new scene. Make a new level. It can be basic, it's fine. Grid's a little boring here. And now I'm gonna create something new here. Normally you'd want to make folders for all these specific things, and you'd want to organize them just so, but I'm just going to keep them all in the same spot here, just so we understand the relationships between all of them. I'm going to right click on the screen, I'm going to create a new blueprint class. Now, type in character, see if I can find our third person character. If you don't have this already, you can easily get it by going to add up in the corner here, or right clicking again, and then clicking on add feature or content pack. You can get the third person pack right here. I'm just going to use it because it's a quick, easy, and convenient character. So go back over here, blueprint class, type in third person. I'm going to add that in here, and then I'm going to call this monster, or BP underscore monster. I save that. This project's source controlled. If you don't see this little symbol, don't worry about it. Now we have a totally custom blueprint. You can see that the parent class is third person character. I click on the event graph, and now we can really make it our own. So I'm going to click on variables here, and then I'm going to add a new variable. However, I'm not ready to do that yet because I don't have the actual variable that we want. I'm going to name this type, and I'm going to leave it Boolean for now. We even have a type, we need to go create one by making a new blueprint enumeration. Now this is where we're going to get our list of types. So we're going to call this element underscore types. And I'm going to press save on both of these. So open up element types, and we can add whatever element names you want. I'm going to do some really simple ones here. I'm going to just do fire, ice, electric, ground, water, and let's say plant. We'll use those 6, and that'll be good. So now we actually have this enum. When we go back to our monster, over here, our monster blueprint that we just made, we change the type. We can type in element, we'll move all the way down here to enums, and we'll pick element type. So, for example here, without setting up an entire procedural spawning system and catching system for our monsters, we'll just pick a specific type. So we'll keep fire type as our main thing here. And I'm going to make this instance editable. So I'm going to click this little eyeball. It also works by clicking this up here. Now, if we put a monster in our scene, we are able to determine the type. It should show up in here. Type in type. If it doesn't show up, just make sure that you're saved first and compiled. There we go. Now you can see we can edit this inside the editor. So if we wanted to change it, we could change it at any time. Great. Let's put 2 of them in the scene. We'll have them look at each other. We might need to write a little bit of logic just for the example of this in terms of how they would select to attack each other. So I'll do that right now. I'm going to go into our monster type here, and I'm going to make a custom event. We'll call this attack. And how it's going to start is it's just going to make a quick scan for overlapping actors. I'm going to find sphere overlap actors. And if any other actors are in the sphere, then we'll know those are the ones that we want to attack. Now, this is a bad example for an RPG. You wouldn't really want to do it like this, but this is one of the fastest ways we can set up a quick interaction between our 2 characters because we do want to see them be able to get hurt. I'm going to turn a class filter on to make sure we're just getting a specific class. So I'm just going to type in monster again. BP monster. One thing that will inevitably happen is that we'll get an overlap of ourselves. So we're going to grab a reference to self by just typing in self, get a reference to self. We're going to drag this out, and we're going to type make, which is going to be a make array. So then we're going to plug the self right into it. So this will ensure that we are never actually including ourselves and attacking ourselves, because that would be bad. We really wouldn't want that. I'm going to start by something about like 200. And for the position, I'm going to reach over here to our self again, and I'm going to get location, get actor location. I'm going to plug this in. Now, just to be sure that we're actually getting things, especially when working with sphere overlaps, one thing I like to do is I like to debug draw a sphere. And I will pass some of the same information over. I'll pass this. The radius is going to be 200. 200 is not going to be very big. So let's make this like 800. I'm going to turn on a duration of 2 and a thickness of 2 as well. I'm going to have the attack on, and I'm going to set it to call an editor. You can see that we have an issue already. It wants us to make an object type, even though we don't really want to worry about this. So we'll just hit make array, and I'm going to get pawn. And also physics body. that should be inclusive of the other characters. What we really want to be sure is that we're filtering them to be able to get the specific blueprints we want. Now let's just do one more thing to make sure things are working. I'm going to type in branch. And then I'm going to pass the return through here. This is basically saying, did we find any actors? And if we did, then pass that on. So if we did, I'm going to grab this array here, and I'm going to type in for each. If it's true, I'm going to drag this out. I'm going to drag this out, type in print, and then I'll just connect these two, and it'll automatically get their display names. So we should see something up in the left-hand corner talking about all of the different actors that show up. Which should just be one other actor for right now, to be perfectly clear. This call and editor thing will give me a little button. Before we test, I'm also going to add in this little print string here. I'm going to say no scan. Now let's test this. I'm going to hit play. And I can do two things. I can either press eject, which will allow me to start selecting characters, or I can go grab them over here in the sidebar. Now, if I type in attack like this, you can see the little button just pops up. I'm going to hit the attack button, and you can see up in the corner here, we have the other monster, right? And we can confirm it's the other monster because we've selected the first monster, BP monster with no number at the end. Now, if we select the other monster, we can see it's going to get the other one. Easy, great. Kind of an annoying stepping stone for a video just about elements, but it's good. Now we're going to set up a blueprint interface. I'm going to call this BPI _ combat actions. And essentially what this is going to do is just make our game a little bit more flexible. We could do all this stuff with just functions and events and all that, but we're going to try and do this the right way. I'm going to call this take hit. I want the language to be really clear because I want to know that one character is attacking the other. This is the character that's taking the hit, so it will take hit. I'm going to make damage amount. This is going to happen right alongside the time that we start building in a lot of our HP and stuff into our characters. We're not going to be able to get into all of that as best as we would hope, but we'll do a little bit of it right now. Inside our BP monster, we're going to make HP. You can make it a float or an integer. I prefer floats for these. Can make combat a little bit more interesting if, characters get hit by point something, but it's not as good if you're going to visibly show people how much, HP is had. You might want it to be an int because ints are whole numbers. So I'm also going to make max HP. We just need a little bit of logic to make this work. So I'm going to open up the default variable. If I press compile, it'll let me change it. I set the max HP to, let's say 20. 20 sounds nice. Sounds like a lot of HP. It's a level 1 character. And at the beginning of the game, set the HP. Set the HP to max HP. Perfect. So we'll have 20 when we get started. Everybody will have that. We can now make attacks because we now have HP, which means we have something to lose. We now have an attack logic, so we can now get an opponent. So let's grab this, and we're going to promote it to a variable. We're going to go opponent. Ideally, you're going to have a better system for finding your targets and attacking them than a sphere overlap. I showed you guys how to make a sphere overlap because it's a really quick way of getting an enemy target and then firing against the enemy target, but it has weaknesses. So it's getting any amount of enemies. So it might grab 5 enemies if we had 5 enemies there. And after the opponent, we're going to be able to call in our BPI combat action. Make sure that this is saved and compiled. And then I'm going to say take hit message. That'll come up. Currently, we do not actually have the interface, so we're going to need that. go up and click on class settings. And then for interfaces, I'm going to hit add, and then we'll type in PPI, combat actions. And now we have that. Because that's the other side of this. In the same character, we have to write an attack, and we have to write logic about taking the hit. So, how much damage do we send over? That's sort of an interesting thing, right? So at this point, we need logic in the middle of this, figuring out who our opponent is, and sending this take hit. And this is where we get into the meat and potatoes of our element system, which is the whole reason you're watching this video. So I'm going to make a custom event. A function would work just as well, but I like that for the purposes of this tutorial, be able to see the custom event that's going to be sitting right underneath here. Type in calculate damage rate by element. Now remember, so we have a type, we have HP, we have an opponent. And because of the same class, the opponent also has the same amount of stats. It's got a type, it's got HP, it's got max HP. So we will type in calculate damage. That'll end up going in the middle. But before we can continue on, we need to make some of the stuff that I showed you that was in my game earlier. We already have our element types. We're going to need to make a data table. I'm going to right click over here, and then I'm going to go to Blueprint, Structure. So the structure defines all the columns in our data table. So I'm going to go Element Properties. Save that. Oops, I spelled it funny. Oh well. So there's all sorts of stuff we could do with this. Let's say like each type, we could have each type have like a base strength. Let's say that fire is just a little bit inherently stronger than other elements, right? So we'll do that. Anytime we do something like this, we're going to call it a rate. A rate being like a multiplier, basically. So like fire, we might say is like 1.1, something like that. You have your structure up here, and then you also have your default variables. So if you click on those, you've got the big 0.0 here. So the base one we want to be 1. Want that, our base strength rate. I personally wouldn't touch this if I'm trying to make a game that feels fair. If all the fire types are just a little bit better, it gets hard to balance that. Type in strong against, or let's just say like effective against. It's important to include a word like against because you don't want to get confused about what's attacking what. So I type in elements again, scroll down to the bottom, we'll get our element types. Now I'm going to make this an array so that we can list out more different elements. That's going to be really, really helpful. We'll type in effective against, meaning so this attacks against another type and it's effective. We'll type in weak against or ineffective. We'll also put in no effect against for anything that just completely nulls out, which would be really cool. Another thing I'm going to add here is color. This we're not going to get too much into in this video, but it can be really great to do stuff like this. I'll use linear color because it's what we use in the that's what we're going to use in UMG, and this will basically let us attribute the same color to every single type later on. So this is great. It's good to go. Now let's right click, and I'll be honest, this is one of those things that's hard to find in Unreal Engine. Like, where is data tables? It's under miscellaneous. So you can click here to miscellaneous data table, or, and this is much easier, you can just type in data table. Just make sure your mouse is hovering over something that doesn't have a little arrow here. Just type in data table. You can click right there, super easy. So it's going to ask you to pick a row structure. So we're going to use our element properties that we just made. I'm going to call this element property data. This is very cool. So now we're going to go in manually. We'll add a new row here. Our types are fire. So fire, we're going to have a base rate strength of 1.0. We'll just leave it. It's a primary element. We're just going to leave it alone. The effective list we're going to make down here. So it's going to be effective against ice and against plant types. In terms of weaknesses, it's going to be weak against water and ground types. And it's going to have no effect. Actually, let's make it weak against water. We'll have no effect against ground. I don't know what my logic is here. You can get into some really funny logic writing these. So the next we'll do ice. We'll keep the base rate. It's going to be effective against water. Weak against fire, obviously. Those two kind of cancel each other out. And it'll have no effect against electric. I'm just making this up as I go along. So just keep doing this for every single type that we have here. I'm just going to time-lapse through this real quick for you. It's important that you make sure that these all match. That's really big. You want to make sure that they are perfectly spelled the same. It's a huge deal. Cool. So now we got our list. We can go back and we can start implementing the logic for all of this. The game I built for the Game Jam has every character attacking with its own type, and that's all it does. Obviously, in a Pokemon game or something like that, you're going to be able to choose a bunch of different types of attacks, which can be helpful here. So let's go ahead and add that. We'll have our character type, but we're also going to have our attack type. If this were a real game, we would add some sort of different structure that included all the different moves you could make, and then we would just use that. We would just use that when determining an attack. I'm going to also make this one instance editable. And I'm just going to drop it down here. Let's look up something on a data table. Table row. Right, it's right down here. It's at the bottom. It's get data table row. I'm going to look for our stuff here. I'm going to get element property data, because that's what we just looked up. So the row names all come in like this, which is super nice. I think this is actually a newer Unreal thing. In Unreal 5.1 on, it'll actually give you a list of all the different row names, which is cool. However, we're going to be using our attack type to be able to do the lookup. So what I'm going to do first is string to enum, or enum to string, excuse me, and then I'm going to pop that in over. Now you can't directly go through, because enums have their own names and they are not they are like machine names. They're not something you want. So I'm going to set this up over here. We're going to look up our attack type, and then we're going to find the row. If the row is not found, let's just print something. I'm going to call this invalid attack type. So we won't want to deal with that. And this out row, this is actually our struct. So if we break it, we can get everything that we just put in. One thing I'm realizing is that our color is actually an array, and I didn't mean to do that. That's a big mistake that I made here. So I'm just going to go back to the element properties, and I'm just going to change this to single. So save that. I'm going to have to go back into our data table for each of these things, and I'm going to have to fix this. Apologies. This is something that drives me nuts, but by default, everything is always completely transparent, which is not great. So I'm going to go back through all of these and make sure they have full opacity instead of being completely transparent. There we go. That looks better. So what we're going to attempt to do here is find out if we have the effectiveness to be able to change things. Currently, we have our attack type plugged in, and we're going to see if each of these contain our enemy's type. Remember, because we also have the type here for all the monster classes. So I'm going to grab the type. It's actually our type. I don't want to do that. Cut that out. So I'm going to grab our opponent that we just saved. I'm going to get the opponent, and I'm going to get type. In order to be able to get his type, we need to be able to cast to monster, and that way we can get information about it as a monster. Now, you don't want to do too many of these casts, but I'm going fast in this tutorial, so we're just going to keep it. In the event that the row is found, we're going to cast the monster here, and we're going to get type, and we need to see if any of these lists contain the type. So for our attack, we're looking up our attack type, and we're comparing these. If the enemy's type is like a weakness of our attack, of all that stuff, then we want to make sure that this is being considered appropriately. So for each of these, and this is kind of not interesting programming because we have to do the same thing a couple times, but we need to make sure it contains the item. Just type in, we'll just plug this in. And then for each of these, if it does, we can pass out this variable. What we're going to do is allow each of these to have the opportunity to change our attack rate. Now, it seems like I'm going a little bit out of order here, right? I'm kind of stream of consciousnessing in this. We're missing a basic attack rate, right? You're sitting here thinking, Woody, we need to put in our attack. Yeah, we totally do. So let's add in a variable. We're going to need attack DMG. This is what I'm going to call this. I'm going to change that to float. Again, you can make an integer if you really wanted to. So our attack DMG needs to be considered here, so I'm going to get it. The first thing I'm going to do is I'm going to multiply it times the strength base rate. The DMG, let's set this to something, we have the 20 HP, right? So let's set this to something like 3. That'll keep things going for a while. So, and then I'm gonna save it again by changing it again. So that happens. This is something we're gonna do in Blueprint that is a lot more fun to do in regular typed code. Like the this kind of logic is gonna junk up the screen really fast, and it's way more efficient when you do it in written code. So if it's effective against, it means we want to multiply this again, and we want to set this. However, you might understand there's a little bit of an order of operations here, right? So we're going to do this through a series of if statements. So we'll plug in an if statement to this branch, type in branch to be able to get it. Obviously, the most powerful thing here, or the most dramatic effect that we might get from doing all of these operations is no effect, right? So if there's no effect, then we actually need to change everything and set the damage to 0. So I'm going to plug this in. I'm going to type in contains again. Before we do anything with our effective against, I want to start with this, with our no effect against. And if the type of attack that we're doing has a no effect against the type that we are attacking, and that's contained, then I want to plug this into an if statement, which basically changes our attack to 0, basically. So if that's the case, we're going to set the attack damage to 0. Or if you want to be kind, you could maybe set it to set the total attack damage to 0.1 or something like that. Like a very scant amount, just a very little amount. It's really important that we do this one first because it's the biggest, most dramatic thing. Now, if this is false, then we can consider our other options here. If it's false, we could do another if statement. So I'm going to type in branch again, and we'll find out if it's effective. If it's effective, then what we'll do is we'll take our attack damage so far, just the regular attack damage. It might have been increased slightly by a base strength rate or something. We'll take the attack damage. And then, because this is super effective, we're going to multiply it by 2. Let's just type in the asterisk, get a little multiply. And then type in 2. And we're going to set the attack damage again. Plug everything in here. And then the last case, if it's neither has no effect, nor is it super effective, and it's weak against, then in that case, we will lastly consider an if statement for weak against. So one last time, pull out the contains here, put in the enemy's type. Our attack is against an enemy with specific weakness. In that case, we'll do another branch. And we're going to find... We can actually just copy the same logic up here. I'm just going to click on all of that. You can control click it all to select multiple. I'm going to press Control plus D to copy it over here. You can also just like click duplicate over here. And this time I'm going to do 0.5. Kind of like what we have going on with Pokemon. And then lastly, we'll set this to 0.5. Not quite as much. Or half as much damage. And this should give us a proper attack damage. So now we know when we're going to take the hit, we're going to feed it our attack damage. Excellent. Compile and save. Now before we get into like taking damage and stuff, which once again, RPGs are complicated, right? You got to think about defense stats, you got to think about attack stats, you got to think about all these other things. We're going to do a simple version of this just to see how our type matchups are effective. But before we do any of that, I just want to calculate the attack damage, and then I just want to run it. So I'm going to do another print string here. This isn't hooked up to anything, so this is going to just, fire, nothing will happen, and it'll move on to the print string. And I want to do an append here. So this can be a really nice way if it doesn't clog up your screen too much. If it does, actually, you can change it to just print to log and not print to screen. But I'm going to have the attack damage and the name of the combatants. So I'm going to get a reference to self. If I just plug it directly in, it'll give me a display name. Our append here is a really great way to make interesting string prints. So I'm going to say is attacking space again, and then I'm going to add the combatant's name. So I'm going to get the opponent, space again, with space, break it again. I'm going to make 2 this time, just to move a little faster. I'm going to get the attack type. I'm going to type to string. Should probably do with an. Space attack for blank HP. Now, how much HP? For now, we'll be lazy because we still need to calculate things like damage on the other side. We could also just call this attack points. Now, something else we can do that's really clever and fun is we can just take the color that we have here. We can take our little color and we can just color it based on the elements. So we could just grab this and just we'll call this just print color for now. And I'll just slide it up here in between things. I know it's getting a little nauseous in these blueprints. I'm just going to slide this up here. A little claustrophobic. And then I'm going to grab the print color, and we'll make our element color into the color of our print string. Also going to up the time on screen because sometimes it's hard to read, especially when we got something long like that. 8 seconds is usually really nice. Like that. Before we test, I'm going to do one more little thing here to make sure that the attack doesn't continue to multiply itself every single time we fire it. I want to set it back to its base value from the beginning. So I'm going to make the attack damage. I'm going to duplicate it, and I'm going to call this attack base DMG. In the same way we have like a max HP, we want a base damage. So the base damage is 3, the attack is 3. That's great. Every single time we calculate, before we even look up the data table, I want to set the attack to the base so that we don't just infinitely multiply everything. I'm going to go back in here, and then I'm going to change our opponent's type. So type. So we're a fire making a fire attack. I'm going to make this an ice character who will make a water attack. All right, so let's play. I'm going to select one of my monsters over in the sidebar over here. This is the fire one that we have. So I'm going to hit him with an attack. He does a fire attack for 6 ATK points. Amazing. And that's what we would expect, that it's an effective attack, so there would be 6. Let's change the attack type. We're going after an ice enemy, so let's change his attack type to water. 1.5 attack points. See, not as effective. Water is not that effective against ice in this system. And let's see what happens with an electric. 1.5 attack points. Also, not that good. Fire, though, excellent. That's a working element system right there. We don't have any cool particles or anything yet, but we have programmed up a little bit of an element system, which I think is really fun. If you made it this far in the tutorial and you don't already know how, I feel like I owe it to you to show up just how to issue damage. I'll also show you how in the game I made, how I set up a health bar. We won't go super in depth with that, but I do feel like I owe it to you. So we make this call to the take hit. We need to implement that. So I'm going to double click it over in interfaces. We set it up earlier in interface by going to class settings and then adding it here. If you forgot, we added our BPI class actions to inherit the interface. So when we take a hit, we're going to take the damage. We're going to make just a really simple one here, and all it is we just need to take our HP, and we're going to take our HP, and then we're going to type in minus to subtract, and then we're going to subtract the damage. So the damage that comes in, that's how much we're going to get. Like I said, in a real RPG, we're going to be doing so much logic, so many different things. We're going to be emulating our favorite tabletop games, probably. So, in terms of how they take damage, that's how all the RPGs are built. By the way, you go back and play Morrowind, it's like heavily inspired by whatever homebrew D&D thing they were doing at the time, and all the Elder Scrolls back since forever, basically. And that's all we really need to do is set the HP again afterwards. That's all it takes. So we can actually see this here without setting up any visual systems. We've already made the HP available by making it visible. And basically, we should at this point be able to see everything. I'm going to take our variables and I'm going to group them up by giving them a category. So I'm going to just type in RPG, and that's going to just put them all in a place where we can see them easily and we like it. And we're going to go attack type. We'll throw the max HP in there too. Attack damage, attack base damage, all that. Now in this little RPG section, we can see all that at once. We can see how much is left. And now we should be able to see our enemies take a hit. So I'm going to call my attack. Attack. Made an attack for 6 points. Let's see if that affected the other enemy here. Go down to his RPG section. You see he took 6 points of damage because his max HP is 20. That totally works. It's not an interesting way to see this working, though. And as promised, let's look at how we would do some visual effects. So I'm going to dip into my library because I already have these, but you should be able to find them easily enough. Now, this is a really great pack, and it's compatible with all the different versions. Now, if you can't get this, you can use something else just as well, and I'll show you how to do it. A little animation, I'll just spawn it for a quick second to just give you an idea of like how you would bring this into a scene. So I'm going to go ahead and add to project. You should be able to load this while you have Unreal Engine open. It's usually not a big deal. In theory, you should probably shut the engine, but this has been fine for me for the most part. So if we go to particles, these are all the old Cascade particles. I thought it was a good example for this, but ideally, ideally you're using some Niagara stuff, some good new stuff. There's both Cascade particles and Niagara particles available for this, which is really cool. We could just drop these into the scene to see what they look like. There we go. So there's an ice attack. Now we'll go back to our BP monster. We'll evaluate this little action. Now that we're done with the main of our content, we can add like a little bit of comments. That DMG logic. I'll just call this fire attack. Now what we're going to do for the attack that we make, we're going to also showcase a little bit of a visual effect. So I'll take that attack type that I have down here. I'm going to take my attack type and drop it here and get attack type. And then I'm going to use this with a select. I'll type in select. And then I've got a select, which is very cool. So I'm just going to leave this to the side for now. What I'm going to do is I'm going to spawn a particle emitter. Spawn actor from class. I'm going to type in particle. I'm going to type in Niagara actor. We'll have that. You can make this a variable if you want. I'm going to leave it here for now. Maybe I'll come back and turn it into a variable. Now I'm going to set Niagara system asset. It'll give me the component automatically. And then it'll allow me to set the in asset. And I can just throw this over here to the select. And this will bring up all the different assets that we could use for this. So I'm going to go back and I'm going to find them. We can use this little button here to click them through. I'm just going to move my screen up a little bit here. Or you could hit the little content drawer at the bottom because it's Unreal 5. Yeah, why don't we just do that? We'll make this full screen, hit the content drawer. Go to our advanced magic, find particles, Niagara. Now I want to use some of these that have like a nice hit. So the hits are exactly what I want. So here's our fire hit. I'm going to press this button. Come back to the content drawer again. Ice hit. Hit that. I'll just skip a bit ahead here. Now that we've got that, we're going to want to activate it. Type in activate. And we can also set its lifetime to be short, so that way it gets deleted, garbage collected, all that. We can set the lifespan. That way it doesn't hang out forever. Let's say about 3 seconds is what you need. Now, if I hit compile, this is going to kind of hate us for it. So we need to do something to be able to get the transform point in. This is a big deal. So what we want is we want our enemy here. So we want our opponent. So we can actually use the opponent actor class that we have here. So we'll get our opponent. And then we'll just get actor location. We can go ahead and drag it here to transform. That's probably fine for now. So let's see. Let's see how it goes. There we go. Pretty cool. So if we change it to ice, we get our ice attack. It's pretty neat. It's so cool. And then at this point, we probably killed this guy, right? Yeah, he's a -10. He's dead. In my game, all the characters get little health bars. That's a really great way to do this. If you don't know how to do this, I'll just show you really fast how I set this up. I'm not going to do it precisely or from scratch. I'm just going to show you what I have in my characters. I have a folder here for widgets, and I have this thing here, which I call name tag, but you should probably just call it percentage or health bar would be good. And all it is just this progress bar in here. This is just something you can go up here and grab, progress. You put it in your widget, and then I just have like legitimately it's just this. There's a widget switcher here, but it does not matter. I don't know what was going on with the widget switcher. I can just, I just changed the color, basically. It's like I just changed the color of it. And then what I did was in my monster class, which in this game is called Fluffy Monster, I just added a widget above the characters' heads right here. This widget, you can't see it because it doesn't start screen space. It starts in world space when you add one in. You go up and you just type in widget, and it just brings in the widget. You want it in screen space. And basically, all that I've done for this is just set a draw size of like 200 by 10, and then it pops up above the head. So in the event graph, after things take damage, we need to update the UIs. Here, I have a reference to the widget. We get the user widget object. This is something that trips people up. You want this to be able to take. This is the widget component, right? But the widget object is the class here, this name tag class. That's the object. So we're calling another interface. You remember interfaces? We made one before in this very same tutorial. And I didn't explain it super well. That is implemented in the name tag as well. If we go over here to the graph, you can see it's got this HP event change, and then we just change the progress of the progress bar. It gets the percent in here, and that's all being calculated over here, which is figuring out the max HP against 0. It's using this map range clamp. This is a super great node. Basically, this is just doing a lot of division math for us. And also clamping things. It's taking the HP, the value versus the max HP. It's saying, like what's at 0, and then, it's mapping it to 0 to 1, which is the floating point percentage that the HP stuff understands. Which is why I used floats to set up this, because we're all working with floats at some point. We're definitely using it when we get into the interface stuff. If that's confusing, there's a lot of other great tutorials out there about how to set up health bars. It's pretty easy to do if it doesn't click with you, but I thought it would be nice to show you because it's like, another RPG standard. There's so many other things you might choose to do with your game at this point. You might want to start adding your defense stat blocks and your attacks, and you might want to start making a roster of different attacks you could make. You might make an array of a bunch of different structs, and they might all be the different attacks that you could use, and like the attacks could all be factored into our little element checker, and then run to see like what the the strengths of those attacks would be. You would at some point you got to start balancing the game, see if all the elements are fair and all that stuff. But I hope this got you started and got you thinking about how fun it is to program element systems.